This program is brought to you by BASF, the chemical company.
Hey, welcome to Stuff to Blow Your Kids' Mind. My name is Robert Lamb.
And my name is Julie Douglas, and today we are talking about magnets.
You've played around with a magnet before. There's probably one in your refrigerator right now holding up some sort of important document or piece of art. And we're going to play around with magnets in this experiment. But as we do so and we witness the power of magnets, we're going to try to explain exactly what's happening.
Yeah, magnets are one of the rare items on Earth that exert control over another object without actually touching it. So let's have a look-see here.
Let's witness this force. We have two magnets here. Each one has a north and a south end. Place that magnet here. Let's watch what happens when I move this one in. Attraction. That's north to south. Flip it around, and what happens? We see repulsion, because north is not going to attract to north and south is not going to attract to south.
That's right, you're chasing after it and it is running away. And the reason for this is because we have a magnetic field, and within this magnetic field we have atoms, and we have a bunch of electrons in these atoms, and they're just pretty hyperactive, and they're creating this activity which is giving us this attraction and repulsion.
Wouldn't it be cool if we could see that magnetic field? Well, there is a way. And all you're going to need is a magnet, a sheet of paper, and some iron filings. Now, iron filings are basically little bitty pieces of iron, and you can buy them just like this, or you can make them if you have a little parental supervision. You're going to need an iron nail, a file, and then you just file that iron nail down into little pieces of iron. So, if we pour these iron filings onto this magnet, we're going to actually see the shape of the magnetic field that's surrounding that magnet.
Yeah, and it's really cool because what you see happening here are these little spikes in the iron filings at either side, and these represent the north and south poles. And then everything between this is the magnetic lines that those filings are actually following.
So there you have it, the power of magnetism right there on the table in front of us. So in order to understand magnetism, we actually have to travel to the very center of the Earth.
Yeah, and when we do, what we find is this solid core of iron. And the solid core of iron is like a big ball, and it's nearly the size of the moon.
Right, this solid lump is the inner core of the planet. And surrounding that, we have a molten outer core.
Yeah, and this molten outer core is really cool because it's almost like an ocean of iron swirling around, and it's really chaotic.
Right, it's basically a magnetism engine. It's producing all of this magnetism around the globe, which is why if you're lost on a summer day, say out in the woods, you pull out your compass, and no matter where you are, you will be able to look at it and see which way points to the very top of the planet, the north, and which way points to the very bottom of the planet, the south.
So think about a U-shaped magnet, okay? I'm holding it upside down so you can see that the north-facing pole is on this side and the south-facing pole is on this side, and everything in between is the magnetic field. And that's pretty much what's happening here on Earth. So not only does it create this magnetism, but it also acts as a shield for our planet.
To understand how magnetism actually protects our planet, we have to travel into space.
And when we do that, we can look to the sun, which is actually pumping out a ton of energy directly toward us.
This is solar radiation, and our planet actually needs this. It heats our world. It provides energy for all the plants that thrive and grow here. But too much of this would be a very bad thing for everybody. It would be harmful to our health, and it would strip off huge chunks of our atmosphere.
Especially if you consider something called a solar flare. And this is basically a storm on the surface of the sun. And when this happens, it actually emits a huge electrical charge of particles on par of 1 million megatons of TNT, and that's a lot of fireworks. And it's a good thing that we have this magnetic field, which kind of acts like an umbrella, shielding us from what would essentially take out life here on Earth.
So when you handle just a household magnet, you're toying with the forces that are both brooding at the very center of the planet and protecting us in space.
This program is brought to you by BASF, the chemical company.